Good afternoon and welcome to this discussion. We've been given this equation from Fourier series. They want us to determine its series up to and including the third harmonic. The quadratic function f of x is defined by f of x equals to 1 minus x over pi, of course in the given range. X is greater than 0 and x is less than 2 pi, and then is f of x plus 2 pi equals to f of x, meaning that the period for this function is what? Is 2 pi. Therefore, they want us to determine the Fourier series up to and including the third harmonic. Now, we know that the Fourier series is given by f of x equals to n0 over 2 plus the summation of a subscript n cos nx plus b subscript n sin nx sin nx. Therefore, for us to get the Fourier series, we need to get the values of the constant a0, a subscript n, and then b subscript n. Once we get them, we come out inside in this equation. Now we shall start by getting the a0. a0 is given by 1 over pi, the integral of f of x dx. Now, from the given instruction, our a0 will be equal to 1 over pi. We are integrating from 0 to 2 pi, 0 to 2 pi. Our f of x is 1 minus x over pi. So that is our f of x. Therefore, here we have 1 minus x over pi, then dx. So we need to integrate this. So this equals to 1 over pi. When you integrate 1 with respect to x, you get x, minus, when you integrate x, you get x squared, over now 2 to 2 pi. Then we are integrating from 0 to 2 pi, so we have 2 pi, then 0. We now substitute in the limits. 1 over pi, we start with the upper limit. Where there is x, you substitute the 2 pi. So here we have 2 pi minus x squared. It will be now 2 pi squared over 2 pi minus, we substitute the lower limit. So it will be, when there is x, you put there 0 minus 0 squared over 2 pi, like that. So this equals to 1 over pi into, now here we have 2 pi minus, when you square 2 pi, you get 4 pi squared over 2 pi minus, this will be 0. equals to, now this pi becomes with 1 pi there, 2 here 1, 2 here 2, so we remain the 2 pi, so here we have 2 pi minus 2 pi, which equals to 1 over pi, 0, which equals to 0. Therefore, we are saying A naught equals to 0. So we have the value of A naught. We can now move on and get An. I'll grab this. Now, for us to get An is given by this 1 over pi the integral of f of x cos nx dx. Now, applying the instruction will be given An will be equal to 1 over pi. Of course, we are integrating from 0 to 2 pi. And then our f of x is 1 minus x all over pi. So we have 1 minus x all over pi. Then of course we have cos nx dx like that. Now we need to integrate this. We integrate by parts. Therefore, this will be our u. This will be our dv. So once we have this, so we are saying u equals to 1 minus x over pi. So we differentiate this, differentiate u with respect to x. du dx will be equal to, of course, when you differentiate this y1, you get 0 because it's a constant. When you differentiate x, you get 1. Therefore, we have minus 1 over pi. That is du dx. And then here we are saying that dv equals to cos nx. For us to get the value of v, we integrate both sides of this equation. So you get integrate dv equals the integral of cos nx dx. When you integrate dv, you get dv. When you integrate cos nx, you get minus sine. Not minus, you get positive sine nx all over that n. So this is the value of v. But integration by parts formula is given by uv minus integral of v du. We now have the value of u, we have the value of v, we can now substitute in this formula. So substituting in this formula, this will be equal to, now our u is this, which is my 1 minus x all over pi. Then our v is this one, so it will be sine nx all over n. Then we are integrating from 0 to 2 pi, then minus, we are integrating from 0 to 2 pi. Our v is this one, sine all over n. Then du, remember our du dx equals to this, therefore du equals to minus 1 over pi dx. This is our du. Put it here, so it will be dot minus 1 over pi dx. So that is our du. We have this. Now we are still here, so we have equals to, you can rearrange this one, 1 over n in 1 minus x over pi sine nx n minus. So from here you can see that we have constants. We shall take negative to come out. This one will be positive plus because of that sign, and then we take out n and pi. We take them out. We have 1 over, so we have the plus 1 over n pi. We take it out. The integral of 0 to pi. Then here we will end with sine nx, then dx, like that. Now we need to integrate this one again. So this will be equal to 1 over n, 1 minus x over pi sine nx plus 1 over n pi. Now, when you integrate sine nx, you get negative cos n x all over n. Then, of course, we are integrating from 0 to 2 pi, like that. This equals to 1 over n, 1 minus x over pi sine nx then we take out this negative and n, so that we have minus 1 over n squared pi. When this n comes out, you multiply with this so that you get n squared, then pi into cos like that. Now we substitute in with the now limits, with the given limits. Now here, when you substitute where there is x, where there is x will be 2 pi, so that here we have equals to 1 over n in 1 minus. Now x, we substitute the 2 pi, so we have 2 pi over pi cos of sine. Now this will be 2 pi n, then minus, we now substitute where there is x will be 0, so minus 1 over n into 1 minus 0 over pi sine 0. We are through with this up to that point. Then we have also this, so it will be minus 1 over n squared pi into, now we start with the upper limit because 2 pi n minus cos, we substitute the lower limit cos 0, like that. Now when you substitute like this, this pi and that will cancel. 1 minus that will make it negative 1. Then sine 2 pi, this one will give us, this one will be 0 when you substitute this, and then of course this one is also 0. So we are remaining with the this cos 2 pi n minus that. So this equals to minus 1 over n squared pi into cos 2 pi n minus cos 0 is 1, like that. So we can rub this again. So we are saying that our n equals to minus 1 over n squared pi into cos 2 pi n minus 1. So at this point we test for odd and even. When n is odd, of course odd is like 1, 3, 5, 7. So when n is odd, we test with 1. So an will be equal to minus 1 over n squared pi into. So now n is 1, so this is 2 pi. 2 pi is the same as 360. So cos 360 is 1. When you use your calculator, you get 1. So this one will be 1 minus 1, which equals to minus 1 over n squared pi times 0, which equals to 0. So we are saying that when n is odd, n equals to 0. Now, we want to test when n is even. Let me wrap this. When n is even is like 2, 4, 6, 8, 10, etc., etc. So when we are testing for even, we use 2. So we are saying that our n will be equal to 1 minus 1 over n squared pi into cos. Now when n is 2, so we have 2 times 2, that is 4. So cos 4 pi. Cos 4 pi is the same as getting cos 720. Cos 720 will give you 1 when you use your calculator, then minus that 1, which equals to again 0. So we are saying that when n is odd and when n is even, an will also be equal to 0. So what we are saying that an equals to 0. So we have this value which is 0. So we remain with Pn. We can now find Pn. Pn is given by 1 over pi. We are integrating from 0 to 2 pi. Then of course f of x, which is 1 minus x over pi. Then this is sine nx dx. Now this is our u. This one is our dv, integration by parts. So we have u equals to 1 minus x over pi. So du dx will be equal to, integrate with respect to x, we can have minus 1 over pi. Therefore, du equals to minus 1 over pi dx. And then we have dv, which equals to sine nx. So to get the value of v, we integrate both sides of that equation. The integral of dv equals to the integral of sine nx dx. When you integrate dv, you get v. When you integrate sine nx, you get negative nx over n. Integrate sine nx, you get negative cos nx all over n. Now, we have the value of v, we have the value of u. Integration formula is given by integration by parts. uv minus the integral of v du. So, to be equal to, we have now u, which is this one, 1 minus x over pi, then times v, which is minus. So I'll start with the minus, then cos nx over n. We are integrating from 0 to 2 pi. Then this side minus integral of from 0 to 2 pi. Our v, which is minus cos nx over n. Then our du, which is this one, dot minus 1 over pi dx. Make up this. So here we have Pn equals to minus 1 over n into 1 minus x over pi cos nx from 0 to 2 pi, and then minus this sine 0 to 2 pi. But before that, you can see here, we can take out pi and n, so that here we have minus 1 over pi n, and then this side and this side will cancel out, and then we have positive, so that inside here we have cos nx, then dx, then dx. Can grab now this. Now we can integrate this, so this equals to minus 1 over n minus 1 over n, and we need to remember the pi that was outside. So we have 1 into 1 minus x over pi cos nx 2 pi 0, and here we have minus 1 over pi n. When you integrate cos nx, then we get sine nx over n, like that. Okay, so at this point, we now have Pn equals to, but I want here you to remember this. Pn was given by 1 over pi into m of x sin nx dx. So remember this pi is outside. It's outside here. 1 over pi like that. So we need not to forget that. Now here we now rearrange this 1 over pi into minus 1 over n 1 minus x over pi cos nx 2 pi 0. Then when you substitute here with the 2 pi sine, when there is x, you substitute with 2 pi and you substitute with the 0, this one will give us 0 at the end of the day. So here we have plus 0 to give us 0. So we remain with this. So here we can take negative 1 over n outside, so that we have minus 1 over pi n into 1 minus x 1 over pi cos nx 2 pi then 0. Now we substitute the limits, so this equals to minus 1 over pi into, we start with the upper limit, so we shall have 1 minus 2 pi over pi cos, now here we will have 2 pi n, then minus, we substitute what the results will be 0, this will be 0 over pi, which will be 0, so we have 1 minus 0, then we have 1 times, so here we have minus cos 0, minus cos 0. So this equals to minus 1 over pi n into, this will be 1 minus 2, when we 1 minus 2 remain minus 2 cos 2 pi n minus cos. Now cos 0 is 1, like that. So this equals to minus 1 over pi into, we now negative 1 minus 2 will be negative 1 times that, we have minus cos 2 pi n minus 1. Because of this negative, then everything becomes positive, so we have 1 over pi n into cos 2 pi n minus 1. So at this point, we will test for even and odd numbers. Now when n is odd, remember I said we test with 1, so our Pn will be equal to 1 over pi n into, remember n is 1, but remember this plus, when you multiply inside by this negative 1 plus, so when n is 1, this is cos 2 pi. Cos 2 pi is the same as cos 360, which is 1, then plus 1. This one equals to 2 over pi n, when n is odd. When n is even, our Pn will be equal to 1 over pi n into, when n is even, meaning n is 2, we test with the 2. 2 times 2, that is 4, so we have 4 pi, so we are getting cos 4 pi. Cos 4 pi is the same as cos 720, which again is 1, then plus this one, which equals to 2 over pi n. So what are we saying? We are saying that Pn equals to 2 over pi n at all even and odd numbers. Okay, now that we have the constants, we can now state our series. Our f of x will be equal to, this is 0, this is 0, this will be 0, so we only have this one, which is now, so we have 2 over pi, we take 1 over n inside, so that we start with it. When n is 1, when n is 1, we shall have 1 over 1, then it will be sine x. When n is 2, we shall have plus 1 over 2 sine 2x. When n is 3, because remember the series exists both at even and odd numbers. So we have 1, we have 2, then at 3, we shall have 1 over 3 sine 3x. Remember they say that you get the series up to and including the third harmonic. Third harmonic we can stop at that point, but we can proceed. When n is 4, we will have plus 1 over 4 sine 4x. When n is 5, then we shall have plus 1 over 5 sine 5x. And it continues like that. So that's how we get the Fourier series of this equation. Thank you for watching and listening. In case you have any queries, any problems, then let me know through my YouTube channel. Thank you very much for watching and listening.